about coherent state and Poisson distribution, and I already showed you the variance to be equal to the mean of weight, mean of the photon number operator. Now let's see if the distribution itself emerge. Okay, when we calculate the probability of getting one particular photon number state. So what I would compute in this lecture is the probability of finding n photon state, that is m cat, is how much. Okay, so definitely this probability of finding m photons would be m alpha mod square, right? Yes, because the coherent state gives us the superposition e power minus alpha mod square by 2 summation n equals to 0 to infinity alpha power n by n factorial the under root n. Okay, so this tells us that alpha would act on alpha would be a superposition over the n photon state. So it could be a 1 photon state, 2 photon state, 3 photon state with different amplitudes. So let's see what is the probability of getting a particular photon state, m photon state. Okay, and of course that would be given by this thing. So let's compute it. I have to compute m bra operated on e power minus alpha mod square by 2 summation n equals to 0 to infinity alpha power n by n factorial under root and then this thing, right? Yeah. Okay. Then what's my next step? I take this exponential outside. Okay. And of course the mod square of this whole thing. Say this mod square. Okay. So I take the exponential outside. So my exponential is this thing 2, and then I have the summation running over alpha power n by n equals to 0 to infinity, and then I have this bra operating on this n, not operating, getting multiplied through the inner product computing. Okay, then of course the mod square of it. Alright, in the next step then we could see that this thing is going to be delta mn. So this conic delta forces the n value to take only the m value. N has a range of values, right? 0 to infinity. But for this thing to survive, the n has to be equal to m, and that is the reason it would boil down to a particular value where n would become m. So I could write then e power minus alpha mod square by 2. This summation is now giving a result for a single value of n when n equals to m. So this becomes then alpha m by m factorial, and then of course this thing becomes 1 and the mod square of this. Alright, now we can see we have to compute the mod square of this exponential and the mod square of this. So this becomes then e power minus alpha mod square, this 1 by 2 and the multiplication from this squared 2 gives me a e power minus alpha mod square. Okay. And then the other thing, this thing becomes alpha power 2m, okay, divided by, this is square root here and this is square here, so this becomes m factorial. Alright, could you get a sense of the Poisson distribution from this result here? No? Okay, let's convert it to a particular expression so that it would look more like Poisson distribution. Let's take alpha square to be some new. Okay, so if I take alpha square equals to be some new, then I could write it as e power minus new. So alpha mod we could also put, or alpha square equals to alpha mod square, something like that. Okay, I could write it as e power minus new, and this alpha power 2m is nothing but alpha square to the power m, so I get nu to the power m divided by m factorial, and this is nothing but getting probability of finding m photons, and this is a typical Poisson distribution. Okay, in our later discussions we would be interpreting this result, that what next after finding it to follow the Poisson distribution.